Hi, and welcome to the Exploring Various Movement Systems section. In this section, we're going to implement various movement systems that you can use in your VR games. In the previous videos, we made an introduction to Unreal's VR editor. The core concept of VR applications is to provide an immersive and comfortable experience for the end user. However, each user has a limited play area, whether we're referring to the mobile or desktop VR. Since we would like to immerse players into a virtual environment, it seems only fair that we have to introduce a way of movement in order for them to explore the environment we have built at their own pace. In this video, we're going to take a look at VR motion sickness and understand the need for different ways of movement inside a VR application. Moreover, we're going to see how these two are related. VR motion sickness is a form of induced motion sickness which differs from your everyday motion sickness. Whereas the motion sickness with which people are most familiar results from actual motion, such as the bobbing of a boat that causes seasickness. The primary feelings of discomfort associated with VR sickness occur when a visual information from a simulated environment signals self-motion in the absence of any actual movement. In either case, there are conflicts among the visual, vestibular balance, and proprioceptive bodily position senses that give rise to this discomfort. The most common symptoms of virtual reality sickness are general discomfort, headache, stomach awareness, nausea, vomiting, sweating, fatigue, drowsiness, and last but not least, disorientation. As you might expect, VR sickness poses a comfort problem to both users and developers. No matter how fundamentally appealing your content is or how badly a user wants to enjoy it, no one wants to endure this type of discomfort. Therefore, it is extremely important to understand the causes of this problem and implement strategies to minimize its occurrence. Let's explore the known causes of VR sickness. It can be difficult to track down a particular cause for VR sickness. Different users have different experiences and sensitivity to different types of stimuli can vary. Moreover, the symptoms can take a while, anywhere from minutes to hours, to manifest. Since you're going to develop VR applications, you will be spending long periods of time immersed in VR, and long exposure to virtual environments can train the brain to be less sensitive to the effects we presented before. As such, dedicated VR developers will be less susceptible to VR sickness than most users. Objectively predicting whether a user will experience discomforts from your content without obtaining feedback from inexperienced users can be daunting. Let's take a look at the particular factors responsible for VR sickness. Some of these factors are speed of movement and acceleration. Speed of movement is directly proportional to the speed of onset of simulator sickness, but not necessarily the subsequent intensity or rate of increase. Although slower movement speeds will generally feel more comfortable, the most important issue is acceleration, which is the stimulus to which the inner ear vestibular organs respond. Acceleration, linear or angular in any direction, conveyed visually but not to the vestibular organs, constitutes a sensory conflict that can cause discomfort. An instantaneous burst of acceleration is more comfortable than an extended, gradual acceleration to the same movement velocity. Degree of control. Taking control of the camera away from the user or causing it to move in ways not initiated by the user can lead to sickness. Some theories suggest the ability to anticipate and control the motion experience plays a role in staving off motion sickness, and this principle appears to hold true for VR sickness as well. Therefore, an expected camera movement, or a cessation of movement, outside the user's control can be uncomfortable. Having an avatar that foreshadows impending camera movement can help users anticipate and prepare for the visual motion, potentially improving the comfort of the experience. Duration. The longer you remain in a virtual environment, the more likely you are to experience simulator sickness. Users should always have the freedom to suspend their game, then return to the exact point where they left off at their leisure. Well-timed suggestions to take a break, such as at save points or breaks in the action, are also a good reminder for users who might otherwise lose track of time. Altitude. The altitude of the user, meaning the height of the user's point of view, can be an indirect factor in VR sickness. The lower the user's POV, the more rapidly the ground plane changes and fills the user's FOV, creating a more intense display of visual flow. This can create an uncomfortable sensation for the same reason moving up staircases, which also creates an intense visual flow across the visual field, is so discomforting. Binocular display. Stereoscopic images can force the eyes to converge on one point in depth, while the lens of the eye focuses to another. Although you will necessarily make use of the full range of depth in VR, it is important to place content on which you know users will be focusing for extended periods of time. Field of view. Field of view in VR can refer to two kinds of field of view. The area of the visual field subtended by the display, which we call display FOV, and the area of the virtual environment that the graphics engine draws to the display, which we'll call camera FOV. A wide display FOV is more likely to contribute to VR sickness for two reasons related to the perception of motion. First, the motion perception is more sensitive in the periphery, making users particularly susceptible to effects from both optic flow and subtle flicker in peripheral regions. Second, a larger display FOV, when used in its entirety, provides the visual system with more input than a smaller display FOV. When that much visual input suggests to the user that they are moving, it represents an intense conflict with bodily senses, leading to discomfort. Reducing display FOV can reduce VR sickness, but also reduces the level of immersion and situational awareness within the application. To best accommodate more sensitive users who might prefer that compromise, you should allow for user-adjustable display FOV. Visibility of on-screen content should not be adversely affected by changing display FOV. Latency and lag. Although developers have no control over many aspects of system latency, such as display updating rate and hardware latencies, it is important to make sure your VR experience does not lag or drop frames on a system that meets minimum technical specifications for the platform you're developing. Many games can slow down as a result of numerous or more complex elements being processed and rendered to the screen. While this is a minor annoyance in traditional video games, it can have an uncomfortable effect on users in VR. Flicker. Flicker plays a significant role when it comes to VR sickness. It can be worsened by high luminance levels and is perceived most strongly in the periphery of your field of view. Although flicker can become less consciously noticeable over time, it can still lead to headaches and eye strain. As we mentioned before, movement can cause VR sickness. Some movement techniques can cause heavy discomfort compared to others. Moreover, depending on your target platforms, you may have input limitations. If you're targeting the HTC Vive platform, for example, you can rely on motion controllers for input. However, if you're targeting a mobile platform, chances are that the player may not have a motion controller. With that in mind, you may have to think out of the box in order to implement a particular movement technique that works well both in your target platform and your game and provides a comfortable experience for the end user.